Are we good?
Are we good? I think we're good.
I hope so.
I think we're good.
I think we're
I
good.
hope so.
I think we're good, bro.
Oh, I see.
Dude, it's great to be back. Today, I'm hyped. I'm excited. I'm energized. I'm
back
ready
in
to go. I love the relaxing music that we have.
Do you?
It's pretty neat,
Very
bro.
chill.
You gotta send me the link, bro. Dude, that's really nice. Really nice music, bro. I'm excited, dude. We got a whole schedule up right now. Got something good, Mike. We've been cooking in the kitchen. Hopefully, Mike likes the dish. You know what I'm saying? And yeah, bro, I'm
to try
excited.
it. I'm excited to try it. I'm back
Yeah,
for the
hey.
second week.
Bet.
They
how you-
said, Lord knows this guy needs extra study, and so we're gonna have him back for a second week. So we're here.
Nah, we got you, bro. That's what we're here, bro. We're here to give you the information, the knowledge that we have to you, my guy. And I'm gonna pass it on to Carlos. How you doing, Carlos?
I'm doing good, man. You know, just learning, chilling. Halloween's coming up.
It is.
Guys.
It is.
Trick or
One
treating?
of, one of the best holidays ever.
I like Halloween.
I don't know about that, bro.
Sorry, I'm obligated to say that.
Oh, okay.
What are
So
you obligated for?
don't worry about it. Don't worry about it.
Oh, okay. I see.
But one of the best holidays ever. You know, the candy, all that good stuff. Costumes.
Wait, do you actually like Halloween?
Of course. One of my favorite.
You sound very sarcastic. I can't
He
tell.
sounds very, I don't know, man. Think twice if you need help, but
Yeah.
One of my favorite holidays ever, dude. Anyways,
I enjoy Halloween a lot. I like
you like Halloween? Yeah.
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 Well,
I
I'm gonna need you to like some LeetCode, okay?
I'm
So
like,
let's imagine LeetCode's a holiday. I'm gonna need you to like
Alright.
LeetCode holiday. We want Mike. Today is another day, another week that we could assist you. Of course, we're not doing all the work. The work has to be done with you as well. But we get to
Yep.
assist you into becoming a better problem solver, getting better at LeetCode, recognizing things quicker, and that's what we're here for. Okay, Mike? That's what the stream is for today.
yes, sir.
I think we have a nice little schedule, a nice little plan for you today. We want to incorporate some pattern recognition like we did last stream. Alright, so that means we're going to give you two problems, and all you need to do is tell us what algorithm or what approach should you take. So you're gonna use the words in the problem and then try to come up with what do you think is the best solution for it. Kind of like a math problem, Mike. You look at a math problem and you're like, oh, you need to calculate the area of the triangle, or you need to find the hypotenuse of something. I don't know, dude. Right? And and then after that, once we're done with those two pattern recognition problems, we're going to do two more problems, but this time we're going to solve them. You're actually going to solve them. One of them, we're going to guide you. We're going to help you. Phone a friend. You can phone us as many times as you want, right?
Okay.
We have unlimited data, unlimited plan. We're on like AT&T or something. And then the second one though, our plan ended. We stopped paying for the plan. And you can't phone us anymore. We're out of data, dude. So that's gonna be the plan for today. That sound good?
Yep. That sounds good.
Alright, dude, it's gonna be fun. Low stakes, man, low stakes. Like, you know, we're not experts here, and we're just here to teach. We're here to learn. We're here to help. Anyone in the comments that wants to give feedback, please do. Okay? And make sure to leave a like and all that good stuff if you want. Alright, so I guess let's get into it. Let me see. How should I do this? I guess, yeah, let's just get into it.
Yeah. Delete the solution. Delete it.
I didn't look at it.
Carlos.
Oh. My bad.
Wait, keep them close. Keep them close. Check the other one. Check the other one.
Check the other
Not
one.
looking,
Okay.
not looking,
Eyes
not
closed. Boom. We're good.
Okay.
Okay. Whew. Thank you,
Yeah.
Jose.
Am I good?
I got
Am I
you.
good?
Got it.
Yeah.
Got it.
Oh, it like just pulled up on the stream. I'm not looking at the stream.
And also, we have a new little overlay. Y'all tell me what you think. You know, we're gonna test it out for today. I'm gonna show it right now. So right now we're in our pattern recognition section of the stream. Dude, we're so tiny now, dude. I don't know. I don't like it, dude.
It hasn't pulled up for me yet.
Hasn't pulled up.
Yeah, me.
What do y'all think? Look at it
Oh,
in
there
the
it is.
screen.
Oh.
I guess it's all right. Yeah. I mean,
I think you could scale this up a little bit like to original sizes, and I think we should be good.
okay. All right. Well, Jose, you know what? How about? What do you think?
Oh,
What do you
no,
think, Mike?
No, because I was gonna say like we could cover the bottom of the LeetCode, but like you would have to stretch us, right? It'd be weird to like stretch the
I could
LeetCode
definitely
area.
do it. How about this, Jose? How about you lead this portion right now while I go fix that?
All right, I got you, brother. I got you.
All
I
right.
got
You know what to do. Pattern recognition.
Yes, sir.
All right.
Yes, sir. All right, Mike. So we have this problem here for you. So the goal is, right, to find keywords and to find. You're not solving this problem. This problem is just figuring out what approach would you take, or what algorithm, what concept would you use to solve this problem. This could be a queue. This could be a stack. This could be a depth first search, breadth first search, trees, anything. 2 pointers, hash table, right? So thinking of all those things, right? We just want you to say like, ooh, this might be a stack, or this might be a queue, or something like that. And that's all. And just give us a little bit of an explanation, like why would that be? And then at the end we'll say like, okay, you got it right or you got it wrong. Yes?
Okay.
Yeah. Alrighty, Mike. Whenever you're ready, feel free to read the problem out loud, and give us your answer.
It's the maximum average subarray, right?
Yes.
Yep.
Yes.
Okay. Maximum average subarray 1. You are given an integer array nums consisting of n elements and an integer k. Find a contiguous. Is that how you say that? Contiguous?
Contiguous. Yes, I think so.
Contiguous subarray whose length is equal to k that has the maximum average value, and return this value. Any answer with a calculation error less than 10 to the negative 5 will be accepted. So for the example, the input nums array equals 1, 12, negative 5, negative 6, 50, and 3. And k equals 4. So the output is 12.75000. Explanation: the maximum average is 12 minus 5 minus 6 plus 50 divided by 4 equals 51 divided by 4 equals 12.75. Example 2, nums equals 5, k equals 1, so the output is 5. There it is.
Perfect.
All right, Mike. What are you thinking, Mike? What's going on in your head?
I'm trying to see how it's working. Let me see. So we have an array nums. It's going to consist of n elements and an integer k. A contiguous subarray whose length is equal to k that has the maximum average value, and return this value. Okay, let me see. 12 minus 51. By 4 is 51 divided by 4.
Question, Carlos. Are we allowed to help?
Let's give them some time a little bit.
Okay. We'll let you marinate it. Let this question marinate in you.
Okay.
Think
so,
of the little
so what
keywords.
I was getting confused about was how it was determining what subarray to choose, but it's saying the maximum average value, right? So essentially,
Okay.
you want like the biggest numbers. So the reason why it started at 12 and ended at 50 for the first example is because that'll give us the maximum average value.
Yeah.
Right?
Yeah.
Okay, I see. And then yeah, okay. So what I learned recently, right,
Yeah.
Mhm.
is that with subarrays,
Mhm.
typically with subarrays, it's gonna be some sort of like two-pointer problem or some sort of
Okay,
pointer
okay,
problem, right? Because you're
okay.
you're getting a section of the
Yeah.
whole entire array.
Yeah.
Typically,
Nice.
the 2 pointers is like sliding windows. So I'm
Okay.
thinking this one is gonna be some sort of sliding window.
Is that your final answer?
Mm, do I have choices or do I just guess?
I think do an educated guess.
Yeah, I'm gonna say it's a sliding window.
Sliding window?
Is that your
Okay.
final answer?
Final?
Are you sure?
Hmm.
Are you positive?
We're just joking,
I'm
Mike.
scared,
I don't want you to. I don't
Oh,
want you
yeah.
to second guess yourself. Let's look at the topics. Wait.
Okay.
Sliding window. Woo!
Yeah.
Mike, let's go, Mike.
Whoa, 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 whoa.
Have
Mike,
a follow-up question.
Let's go. Follow-up
Follow-
question. Follow-up.
Follow-up question. Okay.
Okay.
Follow-up question. So you got 2 pointers and sliding window, right? How would you use, like, would this be a dynamic sliding window, right? Like where you expand, right, one pointer, or would it be like a set size, like the window would be a set size?
Well, I think it would have to be a set size
Okay.
because it's the window size is gonna be based on whatever k is.
Ooh, nice. Yeah. Yes,
Right.
you got that. Yeah.
The only thing that's kind of confusing about that is like with the example, like how it's like how you would write out like in code how to determine the like
The size.
maximum average value that you're supposed
Oh,
to do.
okay.
Like
okay.
like what numbers to choose, but yeah, I'm pretty sure it'll be a fixed sliding window because it's gonna be based on whatever k is.
Okay. That's a valid answer. That's a valid answer. Yeah.
Honestly, I wasn't reading the problem. I knew it was sliding window because of the pre-work we did before the stream.
Okay.
But to answer your question, Mike, this is just off a limb. I didn't even read it that well. But is it saying like if you have a size K, which is okay for this case it's 4, every 4 with every 4 range, you calculate the average and then you get the maximum of it, and you return the maximum. Is that what it's saying? Like this is the first 4 elements.
Well, I
And the
guess that's,
second
I think that's how
elements?
you would. Yeah, so I think that's how you would like determine like what range you would do,
Mm-hmm.
because like you would have to get each window, find its sum,
Uh huh.
whatever that highest value is, you would divide that value by 4. Is what it's saying, I think. Because like it wouldn't be 1, 12, -5, and -6. That's too small.
Well, you
Next one is
calculate the
12,
average of
-5,
that, right?
Yeah. Well, so like that, you see the explanation? So maximum average is 12 minus 5 minus 6
Mhm.
plus 50. That's 51. That would be your highest. And then you would divide that by 4.
Mm. And your question earlier was like you didn't know how to implement it. Did you kind of get it now how you would implement it?
Yeah, I think so. Like, yeah, that was my question. Like, how is it determining, like, what to use? But yeah, no, that makes sense. I think you would like get the first 4, move over, get the next one, get the next one. See what the highest average is. Whatever
Yeah.
that highest average is, you divide that by 4. Yeah, that makes
Yeah.
sense. That makes
Perfect.
sense.
Good.
Perfect.
Nice.
Perfect.
Mike.
Perfect. Clap it
good
up.
stuff.
Clap it up, Mike.
Hold
Clap
up.
it up,
Another one.
Hey.
Mike, good stuff, man. Very impressed. Well, yeah, now, I mean, ideally, yeah, we would want to solve it, but we're going to keep on rolling. We're in the pattern recognition. Maybe another stream, we could solve it for
Maybe
you,
another
or you could solve it on your own time. Or whatever. So, next problem, though, we got this one. So,
Find the K beauty of
Cheers.
the number.
Okay, Mike. Whenever you're ready, man. And also,
Cheers.
also, you could tell me, but I don't know if you need to read the examples to figure out if. What do you think, Jose? Do you think that the examples are needed, or?
Yeah, that way he could get like a little bit of understanding of how this problem is working.
Okay,
think-
okay. That makes sense.
Yeah.
Yeah. If anything, I'll just do like the first one. If that,
Okay,
if
perfect.
that works. If that works.
Just to read the chat a little bit, you know, we got Ali in the chat, so
Hello,
welcome
hello,
Ali.
Ali.
And we got Alex in the chat too.
Welcome.
welcome.
Thumbs up. Thumbs up.
Thumbs
I
up,
think it's
thumbs
thumbs
up,
up.
giving it-
All right. Find the k beauty of a number. The k beauty of an integer num is defined as the number of substrings of num when it is read as a string that meets the following conditions. It has a length of k. It is a divisor of num. Given integers num and k, return the k beauty of num. Note, leading zeros are allowed. 0 is not a divisor of any value. A substring is a contiguous sequence of characters in a string. That first example is going to be num equals 240, k equals 2. The output would be 2. Explanation: the following are the substrings of num of length k. 24 from 240. 24 is a divisor of 240. 40 from 240. 40 is a divisor of 240. Therefore, the k beauty is 2. Okay. Okay.
Okay, Mike. Okay, Mike. What are we thinking? What are we thinking?
This one's kind of confusing. Let me see.
You want to read the second
K-beauty-
example?
Yeah, let me read this one. Num is 430043. K equals 2. Output 2. The following are the substrings of num of length k. 4343. Yeah, 4. Let me see. 04. Okay, wait. Go back up. I think
back
I'm starting
up.
to understand.
Okay.
Yeah, I think I'm starting to understand. Let me see. Has a length of k and divisor of num. Given integers num and k, return the k beauty of num. This one's kind of confusing.
Okay, so look at the keywords.
Substring,
Mm-hmm.
and we are integrating over. It looks like from the examples, we're integrating by one number at a time. Or I guess whatever k is.
Okay. Yeah.
So we're given k already, like right off the bat, right? Input num.
Let's
or-
see. Let's check the description. Yeah. I mean, if the input yes, it says the k beauty of integer base num is defined in a number of substrings of num. When it is
Yeah.
read as a string, yeah, it has a length of k and divisor of num. Okay.
Yeah, given integers num and k. Okay. And we want to return.
We want to return the k beauty numbers. So what determines a number to be a beauty or a beauty number? Go up in the
It
description.
said the number
So
is defined as it has a length of k and it's a divisor
Uh-huh.
of num.
yes,
Mhm.
yes, and then okay. So it has a length of k and it's a divisor of num.
What are you thinking right now, Mike? What's going
I
through
don't know.
your
I'm kind of confused on how this is working. Because like it seems like the output is just matching what k is, which it feels like weird.
What do you mean the output is matching what k is?
Because like k equals 2 and the output's 2 on
Okay.
both examples.
But what is the problem
seems-
saying, Mike? It tells you what the output will be. Like, it tells you how it gets the value of that, of what you're returning.
Don't
Return the
fixate.
k.
Yeah, one thing. Don't fixate yourself like on the input and then the output. You know, See the explanation of like why the output is 2. Yeah. Like why the output is 2, and then in the explanation it tells you why it was 2. It might be a coincidence that K is 2 and the output is 2 on both examples. It might be a coincidence, right? So it might be. So it's not, So I'll read a little bit of the explanation.
I think I'm starting to. Okay, I think I'm starting to see it.
Yeah.
It's basically saying, okay, I think it's basically saying like the substring that we're taking has to be, oh well, I guess it said that, right? But like the substring that we're taking has to be a divisor of num, right?
Yes. Yeah.
Okay. Because yeah, like I think example 2 says it better, right? So 43, it is a divisor of 430043.
Yeah.
Okay. I think I'm starting to see it. There's. Okay, so the reason why it's 2 in the second one is because the middle 3 substrings are not. There's only 2 that are divisors of it. Okay. I see it now. I'm getting it.
Nice.
It's locked.
Yeah.
Okay. Now that you know what input, why you know the reasoning for the input, and you know the reason for the output, now you can focus on the actual how you get the actual function. Like, what's the function to get the output, right?
Yeah.
So visually, the problem actually helps you, I would say, fairly well by bolding the numbers to kind of guide you.
It looks like another sliding window problem, but like instead of being a fixed sliding window like the previous one, this one's gonna dynamically change. You need to like pass through whatever K is gonna be, right?
Okay. Yeah.
Is that what it's doing?
that what final answer?
That's your answer, or what's your answer? I didn't quite.
I think it's sliding window again.
Sliding window.
Can a sliding window just be 2? I don't know, but I think it's sliding window again, based on how it's moving.
Yeah. I mean, I think it is sliding window.
All right, we're gonna hit you with the yay, but maybe I'm a little harsh. It's gonna be a partial yay, Mike. Okay, partial yay. Woo! But not too loud.
Why a partial yay though?
Because
Why partial yay? Why
said,
partial yay?
he said the reasoning wasn't quite correct. But
Okay.
like, cause you mentioned it wouldn't. It's gonna be a dynamic, but the window is fixed. You just gotta shift it over.
Okay. Oh yes. Okay. Yeah.
A dynamic is when you expand the window.
You're changing the window size.
Yeah, you're changing the window size in the problem.
Okay.
Any thoughts, Jose?
Okay, I see it.
Oh yeah. I think, just an overall general thing is that when it's fixed, there's I think there's 2 types of being fixed, right? There's Carlos and Mike are right, but I just want to clarify a little bit, because there's a fixed where you have 2 set, let's say K is 5, and we shift the window 5, and there's the other one where you start at the same point, like index 2, and you move 5 elements until you reach 5 elements, if that makes sense. You can jump into Excalibur.
You're saying you start the pointers in the beginning and you expand until you hit 5?
Until you expand until you hit K numbers. For example,
this
one will be 0 and 2, and then you shift the left index 1, and you recount again all the way to K until you can reach 2 elements, and then you shift the left pointer 1, and then you move right pointer 2 times, then shift element another one on 2 times, and then there's the other one where it's like a fixed size, and you just shift, right? You just shift, right? You start at I, start at J, and you shift both I and J. But like you guys saying, it's a static window.
Yeah.
You know, like a fixed size window, but you just like, you know, a little bit different. One you expand to K, the other one you have K elements, and you shift those K elements, or you shift that 5 elements across. I don't know if that makes sense.
I think it makes sense.
That makes sense.
Yeah.
Mike, I think
Alright,
keywords here are like substrings, of course. If you see anything that says substring, kind of think you're gonna have like a, and if it's an array or like a number or a string, kind of. I guess it would be a string. It's a substring. Then think of like sliding window. Like look into it. It might not always be the case, but that's like a big hint. Like it could be a sliding window.
Gotcha.
And then you kind of know if it's fixed or not because it has like they give you the length K, right?
Gotcha.
If it says something along the lines of like find the most in a substring, find the most, it doesn't give you a size. It just says find the most in a substring or something like that. Then that's like what Jose was talking about. Like you start from the beginning and you count 1, 2, 3. Okay, that's the most right now. And then you shift it over 3, like but with the window size 3. And then you expand it if you find more elements to bring into that window. Does that make sense?
Yes.
Yeah, that makes sense.
Yeah.
So it wouldn't give you like a size K or anything, or it will just hint. It will say something like find the most and find the. It's like So kind of like that. So that's when it will be more dynamic, at least from my experience on looking at problems.
Yes.
Makes
yeah.
sense.
And
Makes sense.
yeah, I think Carter's in the right track. Like when they don't give you K, pretty much when they give you K, it's giving you the window size. You know what I'm saying? And without K it means like until you meet a certain criteria.
Yeah.
Much, like
Okay.
Carter's.
Yeah.
And then it would probably say substring or something. Find the most contiguous in a substring, contiguous in a string or something like that. Something along the lines of that. So, damn, Mike, good stuff, man. Really good stuff.
Hey,
Thank
round
you.
of applause, round of applause, round of applause.
Another round of applause for Mike right now. Let's go, Mike. Let's go, Mike.
Thank you for the clarification on the fixed and dynamic.
Also, do you have a notepad out, Mike?
A notepad?
Yeah. Are you writing notes down, Mike?
I'm not. I
Well,
can get one.
Are you like Albert Einstein with your memory, or?
No.
All right. So.
I think
You can
What do you think?
You can rewatch the stream again then.
What do you think then, Mike?
I think this is okay. I think that'll stick.
Okay.
Okay.
But yeah, no,
I trust you.
I
I trust
definitely
you.
should have some sort of note-taking material.
Either
That's
way,
okay.
we got the live stream is there.
Yeah. Either way,
Go back
this is
and-
documented right now, Mike.
Go back and do
Yeah.
my research
Yeah.
if I need to.
Okay. Now we're into our next segment, everyone. Problem solving. That's not that crazy. Let's go. We're in problem solving now. The next thing we have for Mike. Oh wait, hold up. The next task for Mike is now Mike is going to solve 2 problems. Okay, one of them's gonna be guided. Like one of them, he could phone a friend. He could be like, "Hey, bro, like I forgot how this works. I forgot how that works." And we're gonna be here. We have unlimited data. So call us as many times as you want, it doesn't matter. But once he completes that problem, the next problem we have for him, our line is cut off. We blocked them. Okay? Mike is blocked.
Spooky.
We don't want nothing to do with Mike anymore. And he has to solve it by himself.
Bad friend. Bad friend.
Whoa, I didn't say all that. I didn't say all that, but
Jose.
Nah, I'm kidding.
But
I'm kidding.
something along the lines of that. We're gonna have to cut him off. Our plan is done, and Mike can't call us anymore. So he's gonna have to do it by himself. Okay? Does that sound good, Mike?
Right. That sounds good. That
All
sounds
right,
good.
man. Let me see. Yeah, I guess you're ready to go.
Send me the share.
Oh yes, thank you, man.
Live share. I'll probably join that in there too. That way we can help. I can.
Does
I
it
think
go-
it's
it goes
only
three
two.
ways? Oh,
I think it's only like one. I'm pretty sure. The
I'm gonna
interns
let you
at
join, Mike,
the
then I'll
interns at
join.
LeetCode didn't. Oh, maybe it's
Didn't.
more guests. Try it. Try it.
try it.
Let's get.
Oh wow. Okay,
Is
yeah,
it?
yeah.
Oh, it's only read only though.
Read only. What the?
Oh, mine's not. Mine. Oh wait, no, yeah, it is read only. No,
Oh,
it
it's
says
'cause-
log in.
Yeah, you
You
need to be
gotta
logged
log
in. Log in. You're anonymous.
I'm logging in. I'm logging in.
They want my data.
Alright.
Cloudflare.
Everyone, if y'all are new, if y'all are viewing, please leave a like. Please
I'm in.
subscribe. We do this every week. Every single week, you will see a coding style live stream. All right. All right, Mike. You know the drill. Read the problem. Think it out loud.
Okay.
Tell us what you're thinking. Phone a friend. You know, we're here for you, okay?
Okay.
Try not to phone a friend, though.
I'm gonna try not to.
All right, go ahead.
All right. Count vowel substrings of a string. A substring is a contiguous, non-empty sequence of characters within a string. A vowel substring is a substring that only consists of vowels, which are A, E, I, O, and U, and has all 5 vowels present in it. Given a word, return the number of vowel substrings in word. So input, example 1, input is word equals A, E, I, O, U, U. The output's 2. The vowel substrings of word are as follows: A, E, I, O, U, and A, E, I, O, U, U. So there's 2 there, because it has to contain all 5 vowels. Input word equals unicornarian. Unicornarian. Input 0. Not all 5 vowels are present, so there's no vowel substrings. And then it keeps going. All right. I think I know how to do it. Or like, I think I know what the topic is. Okay. I know we're there at least.
All right.
Question. This might be dumb, right?
No worries. Just
Say-
dumb questions.
Say if it was just A, E, I, O, U as word, right?
A-I-O-U. Okay.
Is that still a substring if it's the whole string? You know what I'm saying?
I believe so. Yeah.
Okay. All right.
Very good
Yeah.
question.
Because
Very good question, Mike. If
Like,
I was
like
example
Mike,
one.
Mike, if I was you, I would, to answer that question, like let's say no one else was with me, I would try to solve the problem and add that test case myself right here.
Okay. At the edge case.
But
okay.
I think Jose's right. It might still be a substring string, but I don't know, honestly. I don't know.
Yeah.
Okay.
You can also look at example one. You see in example one how it's like the second one is a whole string.
Oh yeah, it is.
Yeah.
That makes
But
sense.
like Carlos said, you could also put it on the test cases just to make sure
Okay.
it's a substring and stuff. Yeah.
All right. That's the case then.
All right, buddy.
Let me see.
Alright,
Let me
Mike.
see. Let me see. Looking at example 3.
So you say you kind of already know what? What do you kind of already know?
So it's a substring question
Okay.
that's checking for all the vowels, like A, E, I, O, U, and it's traversing through the whole entire substring. So I'm thinking this is a sliding window problem.
Yes, sir. Yep.
Sliding window problem.
Oh, let me move my cursor from there.
Substring. The substring traversing string. I don't know.
Okay.
Sure, that works. I think this one is also going to be a dynamically changing sliding window.
Okay. Yeah.
Why?
Because, well, I don't really know based off of the description. But in the examples, it's like fluctuating, like the window is changing.
Do they give you like a fixed size in the description, or like something of the sort? Like K
Well,
equals
it
5.
says, yeah, well, I mean, it has the vowels, has all 5 vowels present in it, right?
Okay.
So it has to have all 5 vowels, but I don't think that's the fixed size though.
Okay. So they're not giving a fixed size window or substring.
Yeah,
Pretty
so it's no
Okay.
fixed size.
Yeah.
So technically-
they just give you.
You just need to have a minimum of 5 vowels of all the vowels in it. You can have more though. You can have, like in example 1, you have a W, and that still counts.
Yeah.
Right.
Yeah.
So I guess technically you need a minimum of all 5 vowels.
Okay, that makes sense. Yep, minimum all 5 vowels. I like that. Okay. I don't know if I'm missing anything.
No, I think you have it pretty nice.
Okay. Should I like write out like what the plan is?
Yeah. Write down what your plan is.
Yeah.
Okay.
However you want to do it. my guy.
Pseudocode.
Okay. Well, so a sliding window is typically 2 pointers, right?
Yes.
So we need to set up 2 pointers. Okay. For a sliding window. Okay. Well, I'm blanking. I had something else. Planned. We need to check for the vowels, right?
Okay. Yeah.
Check for all 5 vowels.
All 5 vowels. Nice.
Vowels. We also need to return the vowel substrings in Word. Right.
Okay.
Wait, say that one more time.
So like the third part, return the number of vowel substrings.
Okay.
Like the
Yes.
Output. Returning how many vowel substrings we have. Right.
Also, Mike,
Yeah.
just to give you some transparency, we haven't solved this problem either.
Okay.
So
Okay.
we're right with you. Okay.
Cool.
We'll see how it goes. It's a learning experience for all 3 of us here.
Yeah.
Okay. Alright, I think I'm sort of ready. We're also gonna need like a way to store the vowel substrings we have, right?
Okay.
Um,
We can
So-
do that. We can do that.
Store vowel substrings. Oh, I guess I can do like this. Store vowel substrings and return how many we have, I guess.
Okay.
Man. Okay. I think I'm ready.
All right. So for the 2-pointer, how would you approach it? How would you go about it?
Well, we need to set them up first.
Okay.
I've never set up a sliding window before, so it's gonna be
Okay.
interesting. It is 2 pointers though, right?
Yeah.
So should we do like I and J? Would I and J work as pointers?
Yes, INJ would work.
Okay. So for I'm blanking how to set this up. So for I do this in Word like that.
Let us see. Okay. I'm not sure. I don't think you can do I and J like that.
Oh.
Yeah.
Okay. Let me see. So, should I just do it separately then for I and word and then for J and word?
Yes. Yeah.
Like that?
Yes. Okay. So, let us see. I think that should work. If I'm not mistaken.
They can't be on the same letter though, right? So J has to start one over.
Would it be better? Okay, so would it be better to go by characters the way you're doing here, like traverse each of the characters, or go by the indices?
Probably the characters, right? Because we're gonna be checking for the vowels.
Okay, we can do that. We can do that.
So right now, what are we doing? Is that checking through the string, or is
Yes.
that checking
Through the string. It's traversing through the word. Yeah.
Okay, but is that checking the indices or is that checking the letter?
The letter.
The letter. The letter.
Okay.
Yeah.
Okay. Cool.
Yes. Okay. Let me see. So yeah, we're doing traverse through the letter, but
There might be some pitfalls.
there might be some pitfalls in here, because
Okay.
you are traversing each of the characters. Like in Word, I is gonna go through all the characters. For example, in example 1, it's gonna go through A, E, I, O, U, U. But for each character, J is gonna traverse through the entire string. So when I is A, J is gonna go A, E, I, O, U, U. When I is E, J is gonna go A, E, I, O, U, U. So how would you be able to set I as a starting point, and J use that starting point of I and continue on? Would it be through indices or the actual characters?
That would be through the indice, right?
Yeah.
Because we needed to start in the next one over.
Yes. So if you want to,
is
if you
it?
wanna- it's length.
Yeah, it's not range length. It's just length.
Range length. Range length.
Okay, it is range.
Yeah,
okay.
yeah. My bad. Yeah. Of word. Yeah. Okay.
Yeah.
Not quite. Let me see if I can do it. Help you out
I
in here
think-
with a little bit of.
I think we might need to go into Excalidraw.
Range has start, end, and skip. Right? That's the syntax of it. Default is range. Default is this. This is a default. But we can go to Excalidraw if you guys want.
I
That's
think
just
we
a little bit of
should.
syntax.
We should, so we could see this example right here. How we would do it. I think to visualize it, Mike, I think it will help you understand kind of how you'd want to write it in code.
Okay.
So let me
Okay. Yeah.
Let's do it.
do
Let's
this.
do it.
Alright. Oh, spoiler. Move that.
I didn't see.
Oh, it's okay. Alright. How can I move this? Get out
How
of
did you
here.
use dark mode? How did you get dark mode?
Premium.
I see.
Okay.
Okay.
So you have this string, Mike, okay?
Yeah.
Right now what you have two loops. You have a nested loop. Okay? Like Jose was saying. You have one, this is I, and then this is J. Okay? Group those. Whenever I is at C, that means, and it's a for loop. So for loop stop once it reaches the end. Okay? So if I's at C, then J's gonna go C, U, A, I, E, U, all the way to the end. Once it's done, it starts back over here, and this loop starts again. And then it goes C, U, A, I, E, U, all the way down. And then same thing. This one, this one, this one, this one, all the way down. Right? Is that... Do you think that's a sliding window?
No. Because J is not keeping up with...
Yep.
Like, it's not moving with I.
Yeah. So sliding window usually is a fix, like me and Jose were saying, where you go like 3 at a time. In this case, we know it's not going to be a fix, right? So what you would do is you would have them start either on the same line, and you have logic in your code that says move J only, and then move J only, and then if something doesn't meet the criteria, then that's when you move both of them, and then you move J, you move J, you move J, and if that doesn't meet the criteria, you move both of them, or you move this one I in closer or something like that. That's dynamic sliding window. But you see how it's the J never goes back to the front like it's a window. Once it's open, it usually stays open, or this one comes in closer, right?
Gotcha.
So when Jose's talking about, like, would you rather keep track of the indice or the character? That's kind of what he's talking about. Like, if you keep track of the indice, you know exactly, like, this is 0, this is 1, 2, 3. You know exactly where, you just increment the numbers. So J is going to be +1, it's going to be at 3. And that. Does that make sense?
Okay.
So with that being said, with this example and what the code and what the problem is saying, how should the process go? Like, how would you do it as a human? Right? So knowing that you have 2 pointers or 2 indices, right? Kind of how would you do it? And you could use the example right here. Like, I'm gonna take a screenshot of it. So say on Excel draw, I'm gonna take a screenshot real quick.
Yeah.
Anything you want to add, Jose?
No, that's pretty good. Pretty good.
Pretty good, pretty good.
Okay, look.
Pretty good. Pretty
This
good.
is the example it gave.
Yeah.
Alright. So you tell me, what are you thinking? So the goal is count how
So
many
it has to
substrings.
check. Yeah.
How many
So it has to
substring has
check
all
the-
5 vowels? Sorry,
Yeah.
my bad.
No, you're good. Well, like you were saying earlier, it has to check if that letter is even in the vowels, right?
Uh huh.
So if it's not, we have to move both.
Okay.
So they're both gonna go to U.
Mm-hmm.
And then since that is a vowel, then only J is gonna move.
Okay.
Alright. And now it's gonna check for the rest of the vowels. Right? So A is, so J's gonna move again. I is, so J's gonna move again. E is, and then E is gonna move again to O. And that has A, E, I, O, U.
Okay.
So then it's gonna store that, so that's 1.
Okay.
Right. But it can be longer, is what it's saying.
Uh huh.
So it's gonna keep going for the next one. So boom. So it's gonna store that one. And then it's gonna go again, because it's gonna check the A, and then that's also 1. So boom. It's gonna do it again. It's gonna store that. And then it's gonna go, J's gonna move again to C.
Uh huh.
Or it's gonna check if C is 1. So since it's not 1, that means I is gonna move.
Mhm.
And then does J go back? Since
What do you
C
think?
isn't, since
What you
since
think?
C isn't, I think since C isn't a vowel, it's gonna go back to the last known vowel, right? So it'll go back to A instead. Or will it go all the way?
Yeah.
Wait,
What's the counter at right now, Jose?
Counter
We're at
is
3.
at
We're at 3.
yeah at 3. Counter is at 3 right now.
Okay.
You're in the right track, Mike. You're in the
You're
right
on a,
track.
you're on a great track.
You're
Mike.
you're there.
You're
Yeah,
there.
yeah, no,
Pretty much there.
when I was saying that Jay was gonna move, I thought he was just gonna move back to like the A before the C, like at
Hey,
the
oh,
end.
right here.
Yeah.
Oh,
But it moves to the beginning again.
I mean, you tell me.
Uh,
I thought that's what you're talking about.
yeah.
Like, what do you think
move
would
the
be
arrows.
best? What do you think would be best, Mike?
Mm. Yeah, no, yeah. We should move it. I think we should move J back to the beginning
Okay.
Why?
because if we left it there on the
Uh
A,
huh.
then we would only be checking from where I is at, right? So then only I would be moving, and we'd be leaving out some stuff as we'd be moving it closer.
What do you mean by that?
Okay.
Because so like right now the I is on the A.
Yep.
We would have A E I O U, or we would have A I E U O. That'd be the first one,
Uh huh.
and then we have again the U. That'd be the second one. But like if oh well, I think I don't know actually. I don't know anymore.
No, you're in the right track. You're in the right track.
I'm not saying you're wrong. I want you to like
Yeah.
think it through your head. Like, I feel like you're kind of but you're kind of guessing the explanation right now.
Yeah,
But-
yeah. Well,
but you
like
can
I'm
explain it.
understanding it. It's just. I don't know. That's hard.
So you
Like,
mentioned
I think
if you
I
just
think
move
maybe
it back.
because like I think I like we would need like it has to be some sort of anchor, right?
Yeah.
So like we would have one pointer traversing and then one pointer staying. Right.
Yeah.
Well, you mentioned if you move this back one, right? Yes, you count one, right? You count like, okay, now the counter's at 4 because you counted A, I, E, U, O, U, A. And then going on the logic that you were saying was once you're at a vowel, you move on to the right now. Then you're done. That's not a vowel, and then you move this one. You see, based on that logic you're already going by, you skip the A, I, E, O, U, and the A, I, E, right?
Yeah.
Now, you recognize that you skipped it. Like, you knew that that was the problem. That doesn't mean necessarily you can't go back this way. I mean, maybe there's an approach that you could say like, okay, I can go back, and then I go back again, I go back, and I get those remainders that I didn't get. Maybe. Or you could say, just start right here. Start at the front. And then you count again. 1, 2, 3, 4, 5. And then 1, 2, 3. Like, does that make sense?
Yeah.
So, but I don't know. I don't know what the approach is. Like, that's why I'm trying to guide you on what you think would be best.
Yeah.
But you did recognize that that's gonna be an issue if you just go back like this. So that's good.
Yeah, like you're gonna be missing some.
You're gonna be missing. So how would you solve that? What's the counter to that then?
So we're still on the backtracking, right? Like on this section. Still trying to figure out like moving back.
Yeah, Mike's trying to figure out, okay, once you're right here at U and you count all the vowels and you had a minimum of all 5 vowels, but then you keep going until you're not at a vowel anymore. You obviously you're gonna move I over, but now where does J go? Do you want to backtrack, or do you want to start at the beginning, or do you want to? What do you want to do?
I think we should just start at the beginning, just so it's like a little more structured.
I definitely think
that's what I
that's
was
more of
gonna
a beginner
say.
approach. I have a feeling that like you said, Mike, initially, I feel like there's a way you could backtrack, but I don't know if it's as simple as it's. I don't know if it's as simple.
Yeah, I was gonna mention a little bit or something around those lines. When it comes to like figuring out if it's to backtrack one of this way or that way, or like where to move J, I'd say go to it with a simpler approach. Because if you think about it, you got one loop here, and then you need another loop to move this one back.
Yeah, exactly.
Right, and that loop has to count and check, take a track of I and J, and you will probably subtract the indices and see if the subtraction is greater or less than 5, all that stuff. Another thing is that you have to check if the indices, the values of the characters in here have the 5 vowels, right? The vowels. And then, and if they do, count it as 1, right? And then move J again and again and again, check if it's 5. So it's gonna be a little bit more complex, right?
Yeah, I gotcha.
Yeah, so
That makes
I would
sense, that
say
makes sense.
think of it like a simpler way, straightforward, like you said, structured, right? And like Carlos said, there might be a way to like do J, move it backwards, but I feel like it's gonna be a lot more complicated than yeah.
Rather than just like traversing it from left to right.
Yeah.
Yeah.
Yeah,
Yeah.
that makes sense.
Okay, so what's
All
next,
right.
Mike? What's next? You moved U to A, and then J. Where's J go?
J would have to go to I.
Okay.
And then rescan. Right.
So now what?
Now J traverses again.
What's your current count? Like, what's your current count? How are
So
you
now
gonna? How are you gonna
What?
be like knowing? Okay, I have A. I don't need to look for an A again. I got I. I don't need to look for an I again. Like you could count vowels. Okay, 1 vowel, 2 vowel, 3 vowel, 4. But you need to sort of track how you know you have all 5 vowels in it.
Yeah, well, like, we would just set up like an if statement, right?
Yeah.
That has some sort of like string
Something like
check.
that.
So it would have to be like some sort of like if, I guess like, I don't know, like this is like probably off or something, but like it'd be like if our substring has AEIOU, then it would store it,
Okay. Yeah.
right? It would go
This
into
is
our
this.
count.
Yeah.
But what I'm thinking for the pointers though was that like it would hit something that's not a vowel, and then it would reset the point of it would move I over 1, and then it would reset the point of J to next to I, and then it would just rescan through that again.
Okay.
That's what I was thinking.
Yeah. I mean, that seems pretty good. Now that's the next thing. I think that's the last problem you should figure out. Is how will you know you've counted all vowels are in there? Let's try to figure that out. Because you could count. Okay, 1, 2, 3, 4, 5. Boom, you have 5. Does that meet this criteria? No, because it doesn't have I in it.
Yeah, the line. So then that's when you would get out of the for loops, right?
Yeah, that's when you wouldn't even count it.
Mm-hmm.
So, how do you check? Imagine as a human, like, how would you know? How would you?
Well, isn't that like kind of going like back to what I said though? Like, you would just check if all 5 vowels are in it, and if it's not, then you would break out of it.
So,
Yes,
like an if statement.
but that if statement isn't as specific. It's vague. You're saying, well, I know you're kind of just saying like you're just throwing the idea there. But the idea that you said was, if it has A, E, I, O, U in it, then that's good. But what if it's just A, and you count up to 5? That doesn't have all 5 vowels in it. That's only A. That if statement will still say it's true though, because it's A, E, I, O, U. Like it's if A, if you know. So there needs to be like a tracker of some sort, knowing, okay, I got A, boom, cross it off the list. I got A's gone. I got I, okay, boom, cross it off the list. I is done.
I think the if statement would work if you have some like if S contains A and S dot contains B, or E and S contains O, or something like that, like a and some like around the lines of that. You can use, I would say, like an if statement would probably work. If you want to go A, E, I.
I think it's so long though. I feel like there has to be a better way. But
Yeah.
I guess.
Yeah.
We can do that for now. Just
Yeah,
cover
definitely.
cover the basis.
Yeah, but like Carlos was saying, probably using like a tracker or some sort of it, to keep track of it, could be a little bit better. Cause this thing, as that contains, is gonna scan everything and see if it has an A, see if it has an E, see if it's just gonna be a lot slower. Yeah.
All right, Mike, what are you thinking? We're kind of giving you everything.
I don't know. I just I don't know. I mean, like, are we gonna go back to just programming it then, or?
Do you want to just wait until we get there, or do you want to figure out now? What are you thinking?
I would say let's get the 2-pointer thing started up.
Okay.
And then as we go, we can use the if statement to check that thing, and then we can do a little bit more of improvement, because we are running. We have like 30 more minutes.
Gotta go quick.
So, yeah, a little bit. But
Okay, Mike.
yeah, let's get into some programming.
All right, Mike, you did really good. Now it's time.
Yeah, you did good, Mike.
Tell us how you want to do it. You understand? You literally walked through the pointer situation. You visualize how it's gonna work. Okay. You now just need to translate that into code.
Yeah.
All right. What are the tools you need? Are you gonna need a for loop? Are you just gonna need a counter? Are you gonna need a while loop? What are you gonna need?
Well, we're gonna need some way to store the substring total, right?
Okay. Yeah.
Let's just do total substring. Let's get that out of the way first. It'll easy.
Okay.
I'm blanking. Hello? How do I do this? It's not a list.
Would it be? Okay.
Do you want to return a list or an integer or?
It'll be an integer. Oh, I guess it's 0, right?
Yeah.
So we have total substring equals 0. This is gonna that's gonna be what's gonna update when we have the vowels. Do my for loops look correct right now or no?
I would say update this one. I will update this for loop and update this part of the for loop. So update this and this.
Okay.
Yeah. Is right now here you're traversing.
We're gonna keep track of the indices, right? Not the actual things, is what we said.
Yeah. Exactly. Yes.
And this one, is that how you do it right there?
Yes. Yeah. You got it right.
And this one is wrong.
Yeah. I would say look at the syntax I wrote on line 12 right here. Of how range kind of is set up. That way you can better guide yourself. Because right now you got the length. right? And length, this is going to start at 0 I. 0 is going to go from 0 all the way to length word plus 1. That's how you have it right now. Yeah.
Oh, I see. Okay. Well, I'd have to start from here, no?
Start from there, from the end. Is you
That's
got
the end?
start? Yeah, cause well, right now here you're starting from 0 to length word plus 1. This is a for loop. It's going 0 all the way to length word plus 1. Okay. So now you're going from 0 all the way length from word. So you probably want to do a start, right? So probably right here, do something in there. Where do you want to start? Based on your schedule, where do you want I to start or J to start at?
I need to
Each iteration.
start in the one after I,
Okay. Yeah.
which is what I was trying to do.
Yes.
My syntax is wrong.
Okay. So how do we do that? I want to start at I, like you said. So probably put I in there. I, right here where my cursor is.
All right.
Because look at the syntax. So we need start and skip. So I is the starting now, right? Plus 1. Yeah. There we go. So this is your start and this is your end.
Okay. Okay. Yes,
Yeah.
That makes sense.
Yeah. That makes sense. All right. Bet.
Okay. Okay. Now we're starting.
Now we're starting. Okay. So yeah. So now, okay. Now what do we want to do with our indices?
We need to check if they're hidden a vowel,
Okay. Nice.
right? So if I am confused.
Okay. So one thing I would suggest here, I is the starting point, right? I is gonna tell you from here, and from I is gonna say start here and look afterwards, and keep on looking until you find all the possible vowels and substrings, right? So I has to start in itself in a vowel.
So
Yeah.
we have to check if it's not a vowel then. Right. Like if I does not equal a vowel.
Well, why? What's
Well, because like the way we have it right now, it's just gonna start from the beginning of word, right?
yes? Yeah.
We need to start at a vowel.
Out of vowel? Yeah.
Okay.
Yeah.
So if it's not a vowel, then we need
If
to
it's
move.
not a vowel,
We need to move one.
better move one. Okay.
Does that make sense? Or is there a
Yes,
better way to do that?
that makes sense. That makes sense. I like that thought. That thought is great. That is an amazing thought.
Amazing.
You're on the right track, but
Okay.
you're putting it on the wrong place though.
Oh.
Yeah.
Here's
you,
why,
you,
Mike.
you have the right thought. Keep that thought right. But if I want to move I, where would I put that check? Right of I to move I afterwards. Where would I put that check?
It'd have to be under I. Right.
Yeah.
And
Where
here's
I
why.
was, we were
here's why, Mike.
we were in J, right?
Yeah.
The reason for that is because you don't want to run this second for loop if you don't have to.
Exactly.
So if I is
Exactly.
not even at a vowel, then don't even do this part. You're just
Yeah,
wasting
yeah.
like compute. So that's why you want to check I. Like, okay, let me check I right here because
Yeah.
I don't want to just waste anything right here.
Yeah. Okay.
Yeah.
That makes sense.
Yeah. Pretty much. Hey, nice note there, Carlos. Appreciate that.
Good note. Good note. Good note.
Good note. Good explanation on that.
No.
So if I does not equal. See, this was confusing. How are we gonna check like each vowel here, right?
Okay, so how are we gonna check it if it's a vowel? Okay.
Can I do this? Is that a thing? No. Because
Ooh.
like would that be checking the whole entire?
You could do something like that. You're almost there.
I
You
think
could do something like
I
that.
think so. I think so.
You know what? Let me tell you, Michael. Right?
No.
Mike.
Yeah,
You
yeah.
can have an array called vowels equals boom, and you could say like A.
Oh,
E,
that makes a lot of sense.
Sorry, it's gonna take a while.
No, you're good. No, you're good.
Yeah.
And
Yeah.
kind of like what you said, but all you're gonna say, the way the syntax works in
Vowels.
Python, if I not in vowels.
Oh, not in vowels.
Yeah.
Yeah, with no parentheses though.
Yeah.
Interesting, not in vowels.
Now, you have yeah.
Okay.
So you have the right idea. I think.
Yeah.
I
So
think you
if
could do. It
I
doesn't matter.
not in vowels, I plus equals 1, right? So it's gonna be 1 into C.
Almost. You gotta understand how a for loop works. The for loop is automatically gonna increment to the next word once the loop is done, right? So you don't necessarily have to increment I, but you sort of gotta. There's a key word in Python and in some languages that basically say, don't do the rest of this, but continue. I think it's continue.
Yeah, is it? Yeah, I was gonna say. Wait, I was like, wait, is it just continue?
Yeah.
Okay, yeah. That makes sense. So it says for I, like if I is not in vowels,
Yeah.
keep going.
Yeah.
That's
If
What
you're
is
doing,
I though?
Well, I is. Well, wait. So I is just like the actual position, no?
Yes.
Right. But we're grabbing.
It's sorry to interrupt you, Carlos. I kind of cut you off there.
No, it's okay. That's a valid point.
Yeah.
I was gonna tell him why he's not incrementing as well.
Oh, okay. Bet.
But that's okay. That's another reason. That's another valid point.
Wait. Go ahead, Jose. What?
What's the value of
so
I right
I-
now, Mike?
Yeah. What's the value by?
Well, right now, if it's tracking the position, it's just 0, no?
Perfect.
Yeah.
So what is that line 19 saying?
If 0 is not in vowels.
Perfect. Is there a problem with
Okay.
that?
Yeah, we need to be checking if the vowels are in, like if the vowel is I or something like
Yes.
that, right?
Now, how
So
do you
this
do
would
that?
be the word of I, right?
Perfect.
Yes.
Yeah.
Yes.
Instead of parentheses, it's an array. Or a little
Yeah,
oh, it's
bracket.
array, okay.
There we go.
Yeah.
Gotcha.
And then just to add, Mike, I don't want to add too much to your brain right now, but the reason why we wouldn't do I plus equals 1 is because we would do that in a for loop sake. I mean in a while loop. I mean, if you had a while loop and the value of I like could be incremented, that's when you would do that. In this case, you're in a for loop and you don't need to increment I, it does it automatically.
Gotcha. Okay.
Perfect.
Cool.
Simon! Simon's in here.
What?
Simon.
Hello,
Simon.
Simon.
Simon, what's up?
Whoever you are.
How
Hello,
you
Simon.
doing, Simon? Let's go. Champion right
Let me bring
there.
up this back. Hello,
That's a
Simon.
champion. Oh my god. Being serious right now?
Okay. What happened?
I
I
good.
was trying to do the
Okay.
emojis.
Oh, I see it. Okay. So we're gonna continue. Okay. So now I is set up to hit a vowel first, right?
Yeah.
Now we can start working on J, or like the inside of both loops.
Okay. Yeah.
Right. So now we need to see once we hit a vowel, what do we want to do?
What do we want to do?
What do we want to do?
What
when
did
we
you
hit
do
a
in
vowel?
Excalidraw, Mike? Do we need to go back to go figure it out or no?
Well, I mean, so once we hit a vowel, we need to check if the next one's going to be a vowel,
Yes.
Yep.
right? So I is going to always start at a vowel, right? Because of what we just did,
Yep.
right? Now we need to check if it's going to keep continuing to be a vowel, which is J's problem, right?
Yeah.
Yep.
Yeah.
That's going to be J's problem because I needs to anchor at whatever the base vowel is, right?
Yep.
So Here's the question. I don't know how to syntax that as a problem.
Okay.
Okay.
Verbally
We'll help you out,
say
we'll
it.
help you out.
Verbally say it. Verbally.
So
Verbally.
say verbally say it. So we need to check if J is also on a vowel,
Okay.
right? Because we need it to just like ensure that the next was going to be a vowel in the first place.
Yes.
But we also need to make sure that it's going to be A, E, I, O, U.
Oh, like the 5.
Mm-hmm.
Okay. Okay.
No,
okay.
I'm not understanding that, Mike. You said you gotta make sure it's a vowel, and then you said you gotta make sure it's A-E-I-O-U. That's the same thing as a vowel, Mike.
Well, like it has to be all 5. It has to be make sure it's all 5.
What do you mean?
Oh, I guess we can't do that because J is one thing, right?
Like the substring they have has to have 5. Yeah or no?
Yeah, like the substring has to have 5.
Okay.
Are you saying you
Okay.
need to count if it has A-E-I-O-U?
Yeah,
You need to see.
but J can't do that because it holds 1, right?
Mm-hmm.
Okay. So we need another value then, or like
Let's
another
say-
variable.
We need something else.
Let's go back to the
That
skeleton
can-
draw. I think it'll
Okay.
help you out right
Okay,
here, Mike.
let's just scale a draw, bro.
Okay. Ready, Mike?
Mhm.
So, you're right here. You're really right here, and you're right here. That's currently where you're
Yep.
at. Right now, your J is 1, 0, 1, 2. J is 2. Is this a
Yep.
vowel, Mike?
What?
Is this a vowel?
Yes.
Okay. Have we already found an A before?
No.
How do you know that?
We don't yet.
How would you do that?
We need to have a check.
Perfect. A check or a counter or something.
Yeah.
Okay. Does that make sense? Oh.
Yeah, that makes. Well, that's
is-
what I was kind of.
If the counter is at 1, right? And this is just one way, Mike. There could be other ways,
Mhm.
right?
Mm-hmm.
If the counter's at 1, that means we've never found an A before. So you found an A, and then now you decrease that counter. So the next time you find an A, and the counter's at 0, you know you already found an A, but you can still mark it down. And then once you're done, if you look at all your counter values, if there's one that says 1, that means it's not there. Something along the lines of that. Maybe that logic is not there full, but something along the lines of that.
Okay. I'm a little lost with that, but it's okay. So we're gonna. Do we need another variable then?
Are you, quick question, Carl. Are you talking about dictionary?
Yeah, maybe.
Okay.
Like I was thinking about doing a dictionary, but dictionary doesn't. Does dictionary track like repeated values? Or oh, it does. That I'm thinking of a set. Like a set doesn't track like repetitive values, right?
You do bring a good point there, Mike. You can use a set.
Well, I'm just like I'm not saying to use a set, but I was just trying to remember which one doesn't track like.
Yeah, set
Doubles.
it does. Yeah, set doesn't track doubles. Yeah.
Okay.
I think that is a good approach, Mike. The set.
Yeah, a
You
set
can-
would be a really good approach.
You could potentially here. I'm gonna give you some free tech. Okay.
Okay.
You could potentially. Is A in the set? No, it's not. Added to the set. And that's how you know, like, that's how you would know, okay, is I in the set? No, it's not add. Is E in the set?
Yeah.
No, it's add.
Yeah.
And then,
Kind of like contains duplicate almost.
yeah. And then, once you're at a non-vowel, and you look at the set, right? And if it doesn't have A, E, I, O, U all in it, then that's
it's
not
not.
valid.
Yeah.
Something along the lines of that. Maybe that. Jose, do you have any better approach?
I would say a set would be the best. Like Michael was saying, like set doesn't have a doubles, or doesn't repeat characters, so you can traverse J and be like, hey, add A to the set, add all the vowels to the set, right? Even if it's like A, the set is gonna have one A, right? So we can keep on adding, like we don't even have to check if A is already in set or if E is already in the set. You just keep adding other vowels, and the set itself will filter out all the duplicates, and then we can use the set to figure out if we have all 5 already. So I would say like the set would be the best approach.
Okay.
Let me fix that up for you, but it's gonna be like that, my guy.
What? Okay.
Yeah.
Okay. Man, it's just like I feel like I'm scope creeping now. I'm scope creeping.
What does that mean?
What do you mean?
Like I'm thinking about too many things at once.
Just think of the next step. What's the next step? So you got your I, you got your J, you got I. We're only starting when there's a vowel. Now J. What do we want to do with J? That's the next step. Think of the next step.
Well, we need to keep traversing through the word.
Okay.
We need to check if it's going to be a vowel.
Yeah.
What you know how to do?
You're on the right track. Well,
If
yeah,
word
Uh-huh.
J in vowels.
Yeah.
Okay.
What do we want? Yeah.
Okay.
Now, what else
we
would
need
we
to-
do?
We need to
What else do we
add.
do?
What do you mean? What else do we do? What else do we do? What do you mean? What else do we do?
Okay, so now
word,
yeah.
Now that you know it's a
J.
vowel.
we need to add that vowel to tracker to the set.
Yes. There's something, I'm gonna put it on the top over here. You can do that by doing set.add vowel. Set being the value of the variable that you set the set to. Okay.
I'm thinking, I'm thinking.
It's a function.
Oh, it's
So you put-
it's
yeah. So whatever you want to move. Yeah.
tracker dot add
Yeah.
word J.
Okay. Nice.
Right.
Really nice.
Yeah.
Really nice.
Nice.
Okay.
Okay. So now.
Okay.
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 Now what do we do next? What's the next step?
We need to move J again.
Whoa, calm down.
Oh,
Calm down. What do you want to do with tracker? So now you got the tracker. You added the word J or the vowel into the tracker set. What do you want to do with that information now? Because maybe that J, that new word you added, gives you the 5 vowels you need.
would we have to make another if statement to check if it's all 5?
You're on the right track.
That's
That's all I'm saying.
You're on a
the right
perfect track. One of the best
You're on the
tracks
right
in the
track,
world.
Okay. Let me see. So, if tracker,
Okay.
we need a way to say if tracker has all vowels, then increment total substring.
Okay.
There's a little
nice.
trick, Mike.
Yeah.
There's a little trick to do that.
There is a little trick. Yeah.
Knowing the knowledge you know about sets, Mike,
Mm-hmm.
that there's not going to be duplicates, right? And how many total vowels are there in
5.
the alphabet? Okay. So how can we calculate how much elements are in the set to equal what we know will always be the amount of vowels, total vowels in the set?
If tracker equals 5.
If tracker what?
Yeah.
Tracker what?
The right track.
If
It's a function.
tracker.
It's a function.
Oh, if the range of tracker equals 5.
Almost. You're almost
What's it-
there. If the,
Almost there.
The length.
Yeah.
The length.
Perfect. Let's
Yeah,
go.
yeah,
Let's
yeah.
go, Mike.
Yeah.
Now, how do you use the
Check.
length function?
Like this.
You used it.
Whoa, whoa, whoa,
Whoa, what the?
whoa, whoa, whoa.
What language is
I don't know.
that?
we used it
Hello.
with word. We look at this.
We
look
use
at
it
this
on line
right here.
20.
Yeah, length parentheses.
Look at how we have it set up right here. How you set it up right there on line 20.
Mm-hmm.
How would you do it with tracker now? Get up our range. Just look at
All
the
right, Mike.
what's the
I'll
side
never help
range.
you out.
Okay. Oh.
Now what? What's the value? Beautiful.
Okay.
I like that. I
Pretty
like
good.
that.
That's a nice trick, Mike.
Substring. Man.
There we go. 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 I like that. I like that.
I see it.
Okay. Another question.
Mhm.
Look at line 26. Your indents.
Mhm.
Right. You are saying, okay, if in vowel do this,
Mhm.
and then you're checking if length tracker of 5 do this. Right? Is this
Oh.
so it's running this and then it's running this.
So technically, if word J not in vowels, this will still run.
Not even. Yeah, that would still run.
Okay, so we need to do this then.
Yeah.
Beautiful.
Yeah, exactly.
Oops. Uh-oh.
One more.
Sorry.
Uh-oh. There we go.
Nice.
I think. Nice. Perfect. Perfect.
Okay.
Okay, this seems pretty solid. Now, what does Dominicardos? I think he got it.
I feel like we're gonna run into some sort of I don't know where yet, but some sort of error somewhere.
Hold up. Let me think.
Okay. I would say one thing. There's two things here that I would suggest.
The only thing is that we're not incrementing I at all.
I gets automatically incremented by the for loop. Remember, for loop automatically increments I 1, 0, 1, 2, 3, all
yeah,
the way to the length of word. One thing I would mention here is what happens
I got it. I see what's going on.
when J is not a vowel, right? Let's say it's C, right? What do we wanna do when J is not a vowel, right? What do we wanna do? Second thing is a set, right? The set, once you add it, right? Once you add a vowel into it, that tracker has gonna have that vowel throughout the entire program, right? It will never get resetted. It will never gonna do anything. So for the first trip you do, whatever you add here, set is gonna keep tracker is gonna have that A for the entirety of the program, which could be bad. So those two things I would say, the set and the what do we want to do after J, if J is not a vowel. Which, yeah, those two, this one and this one. Yeah.
Well, if J is not a vowel, we would have to go back
Exactly.
to I plus
Okay.
1.
Yeah.
Right.
Yes. I plus 1. Not
Well,
I
that
plus 1.
Not I plus
But yeah, but you can break out the for loop. Maybe.
We break.
Yeah.
I don't know how break works too much, but I'm assuming we just break out of the for loop.
Yeah, pretty much. If you, I'll do some like if it's not a vowel, break out. That's just gonna help with like making it a little bit faster, the program, because that way you don't have to traverse through the entire thing. Was that what you had in mind, Carlos? Or
No, that makes sense. That's just more of like an efficiency thing. Before,
Yeah,
Mike,
yeah.
just like Jose was saying, before you break, you want to make sure you clear something. You want to clear
yeah.
the set. So what would
How do you wipe the set?
I have no clue.
Oh, you just you just set tracker
Tracker
to
back
equal
to-
set again.
Equal set?
Yeah.
Oh,
Yeah.
okay. So if well, it would still be in here, right? If it's not in vowels.
Yep.
Yeah, you can do it there, I think. Yeah. You can do it there.
Tracker equal set, right?
Yeah.
Back
Yeah.
to 0.
Nice.
Yeah.
And then
Simply
break.
like that. Yeah. Yeah.
Okay.
And then
Then
at the end of everything, what do you need a
Well, we need to return the substrings, right? Total substrings.
Yeah.
Okay. I think
Do I need parentheses here? I'm blanking.
no.
No parentheses. Just return.
I
There you go.
think majority of everything is covered. I think.
Yeah, I think so too.
How about we run it real quick, just to see what's up. Running it.
Let's run it. Run it. Oh,
Oofa.
Oof.
Let me see.
case 3 got 4. Case 1 got 0.
Interesting.
Mm.
All right, let's see what the problem is in here. So we start at I. I not in vowel. Continue. If I is in vowel. Ah, I see. I see. I think so. Yeah, I. We're not considering what I is. Like, if I is a vowel, if I we do consider if hey, I is a vowel, right? If it's not a vowel, continue. If it is a vowel, do the for loop. But we never consider the actual vowel of I. You know what I'm saying? Like we don't track it pretty much. We're not tracking what the value of I is.
we're only tracking J's.
Yeah,
A's,
yeah.
Right? So it's never grabbing that A.
Yeah, exactly.
Yeah,
Exactly.
Okay. I see what you're saying. So wait, should we just do the same thing, like this, but instead of I?
Yeah, you can do
Yeah,
that. Yeah,
works.
that works.
Okay.
Fix the indentation right there. And
Nice,
then also,
nice.
there's another thing we gotta consider if that's the case. Where you want to reset tracker.
That'll still break, right? It still has to run through J. Would it be right here?
I personally was thinking, I don't remember the reason in my head again. I was personally thinking, right when when this breaks, then before the for loop and I ends, you reset it. I forgot what the reason was in my head, but it was because of this, since we forgot to account for I.
Yeah, I think that makes sense, because like as soon as we run through the whole thing again, it'll
Like
just reset.
it might just be the same thing, but it makes more sense. Like Just to ensure everything is clear, once I ends, boom, just reset it. Because you know whenever I ends, then that's it. Like, I is moving on to the next one. You need to restart anyways. So...
Yeah, that makes sense. That makes sense.
that was my logic behind that.
Mm-hmm.
Running it.
Good note, good note, good note. I like it, I like it.
Hey.
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 Hey, okay.
Woofus, mine.
Are we... You're still?
It's your spam.
No, I'm kidding.
Okay, do I submit it? Do I submit it?
Oh.
Yeah, let's submit it.
Let's
Hit
see. Let's go. Good
Let's
stuff.
go, Mike.
High five.
Let's go, Mike.
Oh.
Let's go, Mike.
Mike.
Let's go.
Wow, man.
We love seeing problem solving in action.
Mike, good stuff,
Heck
dude.
yeah.
Now explain it.
Woofus.
Explain the whole thing.
Yes, before you're done.
Alright.
But this is
do
the
it.
last thing. We're not gonna do the other problem.
Yeah, no, that's fine. That's fine. Let's do it. Let's do it. Let's explain it.
Okay.
Ready?
No, you explain it.
Well, yeah. I'm gonna explain. Yeah, I got it.
All right.
Okay. Well,
all
let
right.
me go back to the description.
Okay.
Just
Yeah.
to have both things. Okay. So the reason why we have total substring, right, is because we need to keep track of how many substrings contain all the vowels, right? So total substring equals 0, right? Because that is going to increment up when we have a substring that has all 5 vowels, A, E, I, O, U, right? Now, how are we going to keep track of the vowels, right? We need an array of strings that has all of the vowels in it. So vowels equals A, E, I, O, U, all separately. Should I explain the tracker later? I feel like it's kind of weird to explain it right now.
Explain it later.
Okay.
Man. Explain it later.
Okay. Now we need to traverse through Word, right? So we can see like what the letters are. This is a sliding window problem, 2-pointer problem, so we're gonna have 2 pointers. So we have our for I in range, length of the word. So we have our like indices starting. And then we have for J in range I plus 1, length of word. So make sure it starts at after I. So boom, 2 pointers, boom. Now, right, we need to check where our main focus is vowels in a substring, right? Now we need to check if we're even starting at a vowel, because if we're not even starting at a vowel, we need to move to the next indice and check if that has a vowel inside of it, that value. So if word of I, which means like if whatever indice I is on, if that is a vowel, or if that's not a vowel, right, we need to continue, right? Because we're not focused on stuff that's not vowels, we're focused on vowels. So if that value is not a vowel, then we're going to continue the next one. If that word I is in vowels, so if that value is in vowels, we're going to add it to a set. The reason why we're using a set is because the set doesn't contain duplicates. There isn't duplicates in set. So it'll just keep a nice little set of our values. So like as long as we have an A, or like as long as we don't have like any vowels in it, we're gonna add it, right? So if that value that I is on is in vowels, we're gonna add that to our set. Bam. There's that. Now we go to J, right? Kind of same thing with J. We need to check if J, if that value is in vowels already. If it's not in vowels, then, or well, I guess we should do it. So if that value is in vowels, wait, what? What are we doing there? If word J in vowels, tracker add. Yeah, okay, yeah. So if that value is A, E, I, O, U, we're gonna add it to our set. Like I said earlier, sets don't contain duplicates. So like say if it's an A again, it's not gonna get added just because like we have the A, right? So we don't need to add it to it. And then if the good thing about that is that like we only have 5 vowels and there's no duplicates, right? So if the length of our tracker, right, is 5, that means that we have all of our vowels, right? We have our A, we have our E, we have our I, we have our O, and we have our U. That means that we have a completed substring of all vowels. Now we can increment substring by 1, our total substring by 1, because that means that, hey, our substring contains all 5 vowels, so boom, let's increment that. That's 1. Now, if word J is not in vowels, right? So let's say if it's like a C or any other not vowel, we're gonna break that, and then we're gonna reset our tracker, because that means that, hey, this substring is done. Let's move on to the next one. And then when all that's said and finished and it goes through Word, we want to return our total substrings, and that will give us our output.
Let's freaking go, Mike. Come on.
Go.
Good stuff, man. Dude, I'm going to be honest with you. There's only like... You know what? Why am I going to even be a downer? Never mind, Mike.
Okay.
I was going to say, like, it was going to be a positive thing, but it was going to be like a backhanded positive thing. So, you know what? I'm not going to bother saying that. It wasn't my intention, Mike, but honestly, like, I wanted to just say, like, that was really good.
Thanks, dude.
Literally. That was really great explanation.
Round of
Good
applause.
stuff. Let's go. Another one.
Really nice, dude.
Let's go, man. Good stuff. I'm working on that, Mike. I'm trying to be a better
That's
teacher.
okay.
Sometimes, you know,
That's
I
okay.
could, by accident, you know, I mean, my intentions are good, but it might sound a little bit off, like, you know, so I don't.
No, that's fine. I mean, hey,
You only
if
deserve
I missed
support
something
right now.
or if I said it wrong, you let me know so I can fix it up for later.
No.
for next time.
I think you explained it very well.
Yeah. Nice explanation.
Good stuff,
Thanks, man.
Mike.
I liked it.
Thank you. Guys. Thank
So
you, guys.
what are your
Damn, dude.
what are your key takeaways from this problem?
First things first. Definitely you got to work on that syntax, but I think just like kind of breaking it down, working through the problem like on Excalidraw helped.
Mm-hmm.
Going back to Excalidraw helped, and then kind of problem solving it helped a lot. Like yes, it is a sliding window problem, but like how we set that sliding window problem up, I think this question kind of helped. It was like, yes, it's a sliding window, but there's also kind of like certain things we need to do that are question specific, and I think this question kind of helped that. So
yeah. And you're gonna find that in a lot of problems, like they're gonna still be like sliding window, but they're gonna have like one other problem that it's gonna be different than the other problems that you've done sliding window for. And I think for this one, it was definitely the tracker, like the set.
Yeah. I was gonna say like that was pretty. I thought that was pretty like cool how that kind of panned out.
Mm-hmm.
Like you using a set for it just to see if we have those 5. I think that was pretty cool.
Yeah.
That's cool. I like that.
Yeah, man. Great stuff, brother. Great stuff.
Other than that, dude, I think you did great. I mean, you explained kind of your intention fairly well. And the reason why I kept like asking you, like, you're like, well, I think we should gather the vowels or something. The reason why I like go even like I emphasize, okay, how will you do that? Because whenever you're gonna be doing these problems by yourself, like you probably shouldn't be too vague to yourself whenever you're thinking about like be very specific. And if you're not specific, then that's where you know where your problem's at. You know, okay, I really don't know how I'm gonna start that. Right? So it sort of like kind of guides you. Like, if you accept the vagueness, then you're not gonna get to the actual problem because you're being too vague.
I like
you're like,
that.
oh, I need to get the vowels. All right, how are you gonna get the vowels, right? Like, you know, so
Yep.
I like that.
that's just another thing. That's just like a personal thing. Like whenever you're thinking to yourself, you know, try to think a little bit deeper into it. And if you can't, then that's where the problem's at. You gotta start right there. So
I like that. I like that thinking.
and also, it's very normal to have that. Like you mentioned it, projects. Scope creep.
Scope creep.
That's very common, right? And I think over time you will get better at just like staying focused on what the step you're on, right? And when you get really better, you could probably can think of multiple problems at the same time, you know. So it's just with practice you'll get better at doing that.
Yeah, for sure.
Keeping track of stuff.
Yeah, I think that's what it kind of comes down to, with the syntax and with the problem solving, just more practice. But
Hey,
Yeah.
but give a round of applause to Mike, brother.
Let's go,
Oh,
Mike.
yeah.
Good stuff.
we got through it. We got through it. Yeah.
Now, hopefully, you
Great.
feel a little bit more confident. You know, you got a lot of time, man. A lot of time.
Yeah, no, I definitely do. Like when we started this question, I was like, looks a little sus. But no, I mean, you know, through breaking it down and drawing it out and everything, like we got through it. So that makes
Yeah.
me feel a lot better.
Yeah,
Lot
don't
more
get
confident.
don't get intimidated. You know, break the problem, small pieces, like you did right now. Like first, how to set up the sliding window, then how to check the vowels, then how to keep track of how many vowels we got, and all that stuff. Break it down, because if you see the thing, you're like, oh, dude, I'm intimidated. Break it down, brother. And remember, everything in life got a solution. All right? So you just a little bit of like, you
Is
know,
that true?
breaking it down.
Okay, is that a fact check? Can we get a fact check on that one?
Most of stuff
chat.
got a. It can either be good or bad, but everything got a solution. You know.
Can we fact check that
hey.
one? I need to double check that. I mean, let me find an edge case for that.
Oh.
But no, I think the
Hey.
message is still correct, Jose. I'm sorry. I was just joking
Yeah.
around.
No, I good. Hey, either way, that's
every LeetCode question has a solution.
Got it.
There you go, there you
Every
go.
LeetCode got it. That. Thank you. That's better. Yeah. That phrase, it was told by my kindergarten teacher, so I just took it for granted.
Okay,
Um,
okay.
But yeah, but we gotta fact check that. But yeah, you know, everything got a solution. You know, yeah. So just break it down a little bit. You know, take it easy, take it slow. You know, and eventually you'll get there.
And also,
Okay,
the great
pressure.
thing, Mike, is that every problem doesn't have the same solution. Like,
Yeah.
no, I'm sorry. People solving the same problem, it's not good, just going to be one solution. Like, they can have various of different types of solutions. So, be confident in your approach. Like, you don't have to follow other people's
Yeah.
solutions or whatever, right? Of course, there might be the best solution, but if you could come up with the solution on your own, like that would feel pretty good. Like I just solved it myself, like on my own, right? So
Yep.
that's something that definitely will go through my mind. Is like when I was beginning and me and Jose would do the streams, like I want to get the best solution right away, like first things first, right? But
Yeah.
sometimes, you know, just get a solution done. Like just get a solution, right?
Yeah.
From there, fix it up from there. Caleb, we got a message from Caleb saying everything in life got a solution. Gandhi probably. You know what? That is true. That's probably, you probably said that
It's probably there.
one time, something like that. But
Thanks,
all
guys.
right, I think that's it, man. I think we did a great. You did a great job, dude. Good stuff.
Thank you, bro. Thank you guys
Yes,
for
sir.
thank you guys for guiding me through it and getting me there.
Round of applause. Round of applause.
Round of applause again
round
for
applause.
Mike.
No.
Before we end the stream,
Yeah.
please make sure to like. Please make sure to subscribe. Put on noties on if you want. We stream every Wednesday. Every Wednesday at 8:30. All right, so we'll be here every Wednesday. And then also we got something cooking for next week. We got something cooking for next week.
Ooh,
So,
ooh.
Stay tuned for
I'm
that
gonna be
one.
tuned in.
I've been lacking on
Not
the
here.
videos, everyone. Okay, you put it on me. Put the blame on me. That's on me.
All good. No worries.
But just know we got a big backlog of videos that I could cut up and post, and they're basically clips of the stream, and I could post them. Okay, for the folks that want to rewatch and stuff like that. Boom, that's gonna be there. So that's about it. I think there's really nothing else to say. Anything else? Alexa clapping it up, celebrating. Butter, I'll be here in the
Thank you,
chat,
Alexa.
not in the
Thank you.
flesh next week. Boom.
Boom.
All right.
I'll
Butter.
be here, but not in the flesh.
Butter, I'm gonna have a problem for you to solve, and by next week you should have it solved. And I'm gonna know if you're cheating, if you do decide to cheat on
Okay.
it. So
Okay.
just FYI, that's gonna be a challenge for you, okay?
Okay, that sounds
Alright.
good. That sounds good.
Other than that, I think I'm done. We're good?
All right, guys.
I'm
Yep.
done. I'm done too. I'm done too.
All right.
Sounds
Thank you guys for
good.
tuning in. Thank you.
All right. Thank
Thank you,
y'all.
guys.
See y'all next week.
Bye bye.